I'm just audible, right?
Yeah, sir.
Okay, fine. My screen is visible, right?
Yeah, sir.
So we'll start. So everyone just download that image classification project is there, right? You can download that one. Mm, you just- Okay, so everyone download that. This one, what you can do is like you can go to your GitHub project. I'll share this with you once again. So in chat, I'm just sharing. So everyone download this image classification. So what you can do is like, so code. So you can download this zip.
Excuse me, sir.
Mm. Yeah, Abhishek.
Sir, can you send that link once again? I joined now. It's not available here at the
Okay,
chat box.
shall
Yeah.
I share it in WeJump level 3? Yeah,
Okay, sir.
yeah, it's shared. So everyone, what you can do is like you can just download. So code, download zip. So once it is downloaded, right? So you can go to that folder. So you can extract this, extract all, and then open your Visual Studio and just go to open folder. It was in downloads, right? VJump mini projects. So you can just go to this image classification and you can select this folder. So you can click on select folder. Okay, everyone is able to do that one, right? So if anyone is facing any issues, you can ask now. Okay, I've just given you the code. So today, like we'll see two things. So one is image classification, and the other one is game creation. So first we'll go with the image classification. So can anyone tell me like what is image classification in terms of AI? So have you heard about this one? Anyone?
So image classification, it's like I recognizing images using like pre-trained like data sets.
Okay, so what you told is true. So image classification is nothing about whatever the image you give, right? So computer tries to recognize that image and tells you like what that object is. For example, you can see over here, right? So image classification refers to whatever the image you give. So for example, you are given one image, the cat image, and it will predict as cat. So this is image classification. There is something called as image segmentation, and or else we can call it as localization sometimes. So what this segmentation does is like, so it kind of create where that object it recognize that image, and it will just give a boundary for that one. So that is image classification and localization. And then there is third thing, object detection. So for example, in one image there will be multiple objects, right? So in order to classify that one, we call it as object detection. So there are three things. So classification plus localization, we call it as segmentation in short terms, and then object detection. So any doubts on these three?
Yes, so could you like I did not really understand the difference between classification and
Okay, see,
object
this is
detection.
classification, right? So you can see this is the cat. So it gave the output as cat. So it's just predicting what that image is. So it will give the text itself in classification. Then comes to classification plus localization, right? So you can see this red bounding box. You can see it clearly, right? So it will give you that object where it detected the cat, and it will give you the prediction. And then third thing, if you see over here, there are cats, dog, and duck, right? So in cat, you can see it has been bounded by red color, dog by blue color, and duck by green color. So it will like do color coding box annotation for that one, and it will try to give you the prediction.
Yes, sir. So it's like three different things that we can like train the
So three
model on.
different types of application what you can do
Okay, sir.
in image classification application using AI.
Okay, sir.
So there is one more advanced method. So this is called like I told you, right, the segmentation. So what it does is like it will just enlarge this one. What it does is like whatever the object you detect, right? So it will try to isolate that one. So if you can see over here, whatever the cat is there, it has been marked in blue and dog in yellow. So this is also image segmentation. This is one of the method like where it will identify the object. So any doubts in this? We'll start with image classification as in once.
So can you tell what we should do after downloading the file?
I'll just tell you step by step. Yeah, I'll tell you. So don't worry. I'll just tell you. First, I'll show like how that code will work, and then we'll see step by step. There are three different things we'll see differently, and we'll just try to see. Is that fine?
Oh yes, sir.
Okay. So the given code is direct code, so you don't have to do anything. So the thing is that there are two different codes. One is commented and one is uncommented. So commented one, I'll show it to you later what it will does. So uncommented part, like I'll just show the output and explain like what's happening. Okay. Before that one, I'd given one link, right? This one, reach. Sorry. I'd given one link, right? If I write the number, it was predicting what that number was. Anyone has that link? I think so. I shared in WhatsApp, right? Okay, so I'll start with the very basics of neural network model. Have you heard about neurons in your body, right? Has anyone heard about neurons and nervous system?
Yes, sir.
Okay, so how does it work? Like any idea you have?
Yes.
They transmit electric signals.
Okay, so they transmit electric signals. How do they get to know, like from which this neuron electric signal has to transfer? There is something called as what is it? I forgot the name. So where that electrons inside your neurons, right? So it will get activated. So inwards and outwards, something uh, concept is there, right? So if you have studied biology in that one, so similar way. Just a minute, I have one image to show to you. Mm, So this one I'll just share this with you all. This is very important. Like if you want to learn in depth for like what is neural networks. So I'll just teach you in next class on Wednesday. Is that fine? So what this neural network does. So before I'll take 15 minutes of time and I'll teach you in depth like what neural networks are in the artificial intelligence. Okay. So before we start, uh, this whatever image classification happens, right? So it will happen in this neural networks. So when they started building artificial intelligence, right? They started with this perceptron. In perceptron, what there will be is that three layers will be there. One is input layer, one is the hidden layer, and the output layer. I'll just show it to you in notepad. There is input layer, so three layers would be there: hidden layer, and then output layer. Okay, so what input layer does is like we'll just feed the image over here in the input layer. So what hidden layer does is that it will like kind of do the calculation, and then in output layer there will be output, whether it's cat or dog or something like whatever the image you give. So this is the basic neural network, how it will work. So first you'll give the input, then it will try to do some calculation in its hidden layers. Then it will give you the output, whether it's cat, dog, or some other object which you're trying to classify. So this is the basic neural networks. Networks. Okay. Then there is something called as convolutional neural networks. Convolutional neural networks. So has anyone heard about Google Net or DenseNet or AlexNet, something like that? So recent, whatever we are doing right now, right? So we are using convolutional neural networks. So this is the recent advancement in classification. In this, we have over around 1,000 CNN networks, so which everyone can use in classification. So we'll just try to use two or three models, and we'll see. In order to list those, we have AlexNet, then we have DenseNet, then mostly GoogleNet is there. Then we have DenseNet 121 also and ResNet. So these are the different combination of your neural networks. So if you can see over here, right? So hidden layer, sorry, input layer. Input layer is the yellow color one, and this pink color and green color you can see, right? So these are the hidden layers. Then whatever is there in orange, these are the output layers. So these are arranged in different patterns in order to calculate for giving you better accuracies. So that is why there are thousands of neural networks where you can use. So as of now, the popular ones are, which are listed out over here: AlexNet, DenseNet, GoogleNet, and ResNet. Any doubts on this one till now? Anyone, any doubts?
Also,
Okay, so just make sure like you just understand the very basic concept. First you'll give the image, then you'll calculate like what that image is, and then you'll try to predict whether it's the object. So there are multiple CNN models, so convolutional neural networks, which we mainly use for images. So make sure you remember this one. And then there are different kinds of popular convolutional neural networks. So AlexNet, DenseNet, GoogleNet, and ResNet. So there are multiple more. We don't have to worry about those and all. So these are the best performing neural networks in order to classify or do object detection and those kind of things. Okay, I've shared this one,
Excuse me,
right?
sir.
Yeah.
So could you like I have a doubt, like how do they actually work?
Okay. So how do they actually work, right? Okay. So like as I told you, right? So when your neurons activate electrical signals, there will be something called active potential and inactive potential. I think so. In neural network will come. So similar way. Uh, just a minute. I'll just show it for the very one basic layer. I'll show it for you. So this is input layer. Sorry, I can't write over here. So this is input layer. This is hidden layer. Then there is output layer. Okay, so this should be interconnected. Okay, once you give the image, right? So this is where your image is present, input layer. So you'll just give the image. So my handwriting is bad. So just remember, in this yellow color one, you're just giving the image, and then just take one more color. So I'll take it as blue. Yeah. So in hidden layer, there is something called as activation functions. Activation functions, sorry. So what this activation function does is like whenever when any condition is satisfied, right? So it will let you like that output. So for example, there is dog. So dog, and then there is cat. So what activation function does is that, so whenever it's dog, so like it will try to give the prediction as dog. So based on the value calculated, so that is there in very depth like how it's calculated. So but make sure this activation function is the thing which will result in whether it's dog or cat. So whenever the calculation, for example, mm, for example. Have you heard of? Okay, so in mathematics, have you seen your graph, right? So this is your graph. Just give me a minute. Okay, so you know this graph, right? What is this axis? So
Y-axis.
which axis? Y
Y.
axis, yeah. So y axis. Then this is x axis, right? Sorry.
Yes, sir.
Okay, so x axis. So let's just say this is value 1 and this is value 1. So zero point 0.5 will be there. 0.5. So this is 1, right? Till 1. So there is some mathematical equation. So how can I represent y would be zero point 0.5 and x till 1? So there will be some equation, right? So what
Yes,
we
sir.
do is that, so there will be some equation we'll be giving over here for the activation function. So whenever it satisfies, so whatever the value above zero point 0.5 or something like that, so it'll predict as cat. So whatever value below zero point 0.5 will predict as dog. Like that calculation will be giving for the CNN model. So it will calculate based on accordingly. For here, I'll show you an example. So we'll write 2, right? So I'll draw my number over there. So you can see if it's showing me a 6. So 2 is written properly over here, right? So what happens is that, so you can see this 2 number written, right? So this is how images pass through your neural networks. So then this is what I taught you, right? NumPy and matrix operation. There will be convolutional matrix operation. You think of it as some calculation is happening as of now. So what we do is like we convolve each and every layer. So if you go convolving each and every layer, right? So this is how two would be differentiated by the system. So computer recognizes two this way in each layer. So you can see like some pattern like kind of giving you two, right? So you can see over here. So like it became from black. So whatever it's there, two it's kind to do. And as you go on, like the number of pixels will reduce. So you have to at the end you have to predict to one value, right? So this is how it will be pointing out to 2. Just a minute, I'll connect. So if I go further and further, like this pattern will become smaller and smaller, and it's not understandable by us. But system makes sure, like it will make sure it will be able to understand from the pattern, like after the calculation of that convolution. So at the end, so whatever the value you give, right, it's predicting as 2. So similar way, we'll do it for dogs and cats also. Okay, I'll just show you one difference. So like if I give you this one image, right? So how will you be able to tell whether it's cat or dog?
So we could notice the ears
Okay, ear thing.
and the face, the length of the snout
Okay, this one length,
and tongue.
and then tongue also. Okay. Then what's the main difference over here? The cat, like it has shorter face, and then like kind of pointed ears, always towards up, and you can see the difference in their nose as well, right?
Yes, sir.
Okay. So what system the AI system does is like it will just remember this nose is different for dog, this ear and eyes are different for dog. So it will keep a note. So we'll what we do is like for AI models we train on this one. So we'll train for 1,000 times, 10,000 times, 20,000 times. So when we train, it will be able to understand this pattern. So this nose pattern it will be able to understand, this eye pattern, then this ear lobe pattern. So it will try to keep it in its memory. So whenever you give that one particular cat image next time, right? So it will automatically detect. So that is the main idea of convolutional neural networks. So we train using multiple and thousands of images at a time, and it will be able to recognize the patterns. So if you see over here also, similar way, 2 has been trained like multiple times, it will become this way. At the end, it is able to predict, right? So if I write it as 3, so 3 it was able to like train over here and over here and over here. So at the end, whatever I give, it's pointing out to 3. Whatever I do the calculation, it's pointing out to 3. Majority of the percentage it will take, and then it will give you the percentage like that prediction percentage is 90%. So I'm saying it as 3. The value is 3. So if you can see over here, right? So first guess, whatever it made, so it was giving us 3, and second guess, whatever we have written, it is representing as 1. So it will have other values also, whatever the highest percentage it gets. So activation function does that. So whatever the highest possibility it has, so it will give you that output value as the output. So any doubts in this one? Anyone any doubts?
No, sir. Excuse me, sir. Excuse me, sir.
Yeah, Tanishka.
Sir, like you told us about the graph, like we understood, like how is it like related to the neural networks that you told?
No, just a minute. Just a minute. Can you give? Yeah, sorry about it. So the graph representation which I gave, right? So there is some. Sorry. This one, like, see, there is a condition. I set a condition. So if it is greater than zero point 0.5, so I'll tell it as cat, right? So CAT, cat. So if it is less than zero point 0.5, like I'm just giving some relatable things. So if the value calculation, whatever the calculation we do, right? So if it is less than zero point 0.5, so I'll just mention it as dog. So in real case scenario, it will not be the case. I'm just representing like how you can relate this activation function. So whatever value, like after the calculation, everything comes right. So one value I'll get. So if I get zero point 0.7 or something like that, so then it will tell us cat. Then if I give it as point 4 or something like that, right? So it will tell me as dog. So for relating to that one, I'm just gave this graph.
Excuse me, sir.
Yeah.
So you were saying about matrices also, right? Like, is it like you were also saying that images will be stored as like pixels will be stored as matrices and all? Is it like the image we give will be like separated as matrices, and then on that matrices calculations will be made and then predictions?
Yeah, like what you understand is true. So when we give images, right? Like I kept on telling you, like images, three-dimensional values. So where you'll be having RGB values. So when you give an image, so this how it will be the pixels. So how it will be represented for the neural network as well. So as we do convolutional neural networks, so if you can see, right, I just pointed out to one of the pixels of the convolutional one. So like in like this, I'll just remove. Like if you see over here, it came. This many pixels were selected. So in order to get this pixel right, so we do convolutional for that many. Like if you can see at the bottom three, right? This over here, it was pointing out to so many things, right? So that many pixel value it will take, and then it will try to do calculation for that one. So it will be in the matrix form only.
Okay, sir.
Okay. So shall we go for the output? This is the basic, but there is in depth. But if I tell you in depth also, right, for your understanding, you will be able to understand. Just keep in mind, whenever you try to do classification, we will use convolutional neural networks. And in convolutional neural networks, we do some matrix calculation. And at the end, output layer, we do try to predict the based on the objects. There are multiple objects. So this is the basic idea. So input layer, hidden layer, and output layer. So there is image will give us input. We do some convolutional calculations, and then at the end we'll try to predict, like from whatever the image we are given, cat or dog, or any other object. So this is the basic idea. So I do understand, like let's just telling little bit and trying to get you the overall picture. It doesn't make sense. What is image classification and so on. So if you have any doubts, like we'll clear it now and here itself. So you won't get confused later. Or else it outputs. I'm audible, right? Yeah, participants is nine.
Yes, sir.
Okay, so if you have any doubts, like we'll clear it now and here itself, so you won't get confused later. Okay. And you can open your code, sorry. You can open your code through Visual Studio Code. Yeah.
Excuse me, sir.
Yeah, Abhishek.
Yes, sir, this is the zip file, no? That you said to
Yeah,
us.
this is the zip file. Once you extract this
Yeah.
one, right? So if you
So,
extract the WeJump mini project and if you go inside this one, there is image classification folder. So open this folder inside this one, whatever it's there.
sir, about the extracting thing, can you once again explain that?
No, this is just simple. Like whenever whatever you download, right? I'll just delete this one. So if you just right click, you'll get as extract all, right? So it's there in both Windows 10 and Windows 11. So you can extract it directly. So once you extract this folder, you'll get. So you can open inside this one and you can see image classification. So open this folder in your Visual Studio Code. So we have to install CV2, import CV2 we are using, right? So we need to pip install this one. So pip install OpenCV, you can just type pip install OpenCV. So I'll just share this with you. I'll share it in WeJump group itself. So everyone did this one. Pip install OpenCV. Wait, I think so. This. Okay, you can type this as well. Mm, so if that doesn't work, you can type this as well. OpenCV Python. Yeah, this you can try. It will work. Pip install OpenCV minus Python. So I'll remove this one. You'll get confused. Okay, so just forgot to tell you. Like I was telling you, there were multiple very is that popular convolutional neural networks, right? So there were many, right? So ImageNet is one of them. So what we'll do is like we'll use this ImageNet in our project. So this is important. So ImageNet. So this is one type of convolutional neural network. And for your reference, I'll show you like how many layers ImageNet has. So you can see over here, right? So this is what they're trying to do. So they'll give the input. This is your hidden layers, and then you'll try to give the output. So for your number of layers, okay, this is just the block diagram. Okay, so if we come over here, okay, so this is VGG16. I mentioned it. Okay, so can anyone tell me what is this 224 cross 224 cross 3?
Order of the matrix. Is it
Yeah,
like
this
that?
is the order of the matrix. So it has height 224 and depth 224 and then 3 layers, RGB layers. So that is your image which you give. So then what we do is like we do use convolutional methods. So each layer we iterate this image and we'll try to get the output over here. 1000 you're getting whatever value you're getting, right? So we'll try to make it to a single value at the end. And then we'll try to predict the output. So that is the main idea. So image will pass from the input layer. Then in the hidden layers, we try to pass, do some calculation, the whole image, and then we'll try to iterate it to single value at the end. So this is just for your understanding how it will happen in each layer. So you don't have to worry that much about this one. So calculation happens. So you don't worry about this. So first image will pass, we do the calculation and then we predict. So you got the overall like some idea, right? What's happening? So this one you are seeing other dimensions, right? So that is that dimension are how the image is reduced. That matrix size it will be reduced after calculation. Sixty. So any doubts in this? So if you are
No, sir.
okay, so you can type. You can just start it. Python app.py. So it will start your Flask server. Once you start, like this one is there. So this I have developed for three different things. One is image classification, then object detection and video detection. I showed you some outputs, right? That itself, like we'll learn these three things. We'll see it over here. Okay, I'll explain the code part first, or else I'll give you the outputs. I'll show you how it's happening. So just download one image. Just mm, wait. We'll have this image. I have tiger image. Then we'll have lion image. So what's the common three things which are the three images whichever I downloaded, right? What's the common thing? Anyone?
So they are cats.
Okay, so they belong to the cat family. So if you come to your classification, they're cat family. So all belongs to cat family. I downloaded this because so this water neural network model is there, right? So it will be able to differentiate. Then we have one horse image. Okay. So whenever I choose file, right? So I'll just give this as cat first. So I'll click on open, upload and predict. So once I do this one, it's giving me as tiger cat. So this because it's there are some patterns representing this tiger patterns, right? So it's giving me as tiger cat. Just I'll choose one more. I'll just select the tiger itself. So it's giving me confidence with tiger. So this is the confidence level. Okay. Need to okay, just a minute. So make this 10 everyone. So it's okay, sorry. I can reduce this one. So so it's giving you in 100%. So just one small correction. So in line 220, 213, right? So make it as 10 instead of 100. So we are rounding off to confidence level to 100%. So it is telling me this whatever the prediction is done, right? So 89.72 percentage. It is predicting me as tiger. So choose a file. So it gave me the prediction as lion. So this is 89.9 percentage. Then if I choose other image, so common sorrel. This is a type of horse. So this one we are given in, just a minute, I'll show it to you. So it should have given hours only, right? So this what is sorial hours? They call this one as orange, like sorry, brown and white striped one.
So in line 213, like what was the change that you told us to?
And this was 100, right? If you see the line is 100, so what you need to do is like just make it 10 and save. So that is because like it's going above 100%, right? So calculation mistake. So you can make it to 10.
Yes.
Okay. So anyone tried this image classification?
Yes, sir.
Okay. So you're getting the output like proper, like little bit properly, right?
Yes.
Okay. So I'll explain the code. So if you come over here, right? What we did is like for image classification. So if you can see over here, ImageNet labels and efficient .onx file is there, right? So what we did is like someone has already trained the efficient model and ImageNet model. So we took this whatever they trained, right? So we call them as trained weights. So you don't have to worry about that one. So whenever you train any convolutional neural networks, we do get output like trained data as weights. So we call them as weights. So whatever you train on convolutional neural networks, so we'll have some residue. So whatever it has learned, so we call them as weights. So this weights someone is already trained already. We are taking that one. Okay. For example, if you can see over here, 1,000 things are there. ImageNet labels.txt. So whenever someone trains, right? So they would have trained it for 10,000 object, 1 lakh object, 2 lakh object. So anyone knows about uh, sets, images? Uh, okay. There is something called as for everyone. There is CIFAR 10, CIFAR 10 images. So what the CIFAR 10 images as is that? So they'll be having like 1 lakh objects, like different objects. If you can see over here, I'll just show it to you. See, there were a large repository of images. So they've already characterized that one and they've taught the neural network model. So these images are like for aeroplane, these images for automobile. Then these are for birds. These are for cats, deers, dogs. Like they already have that huge repository. So we don't have to download, we don't have to train the neural network model once again from scratch. So someone has already trained. We are taking that one. So whatever they have trained on the CIFAR 10 images, so we are utilizing that one. So for that reason, uh, efficientnet underscore b0.onx is there, right? So this has been already trained. These are the values you don't have to worry about. So then ImageNet labels. So if you come over here, these labels are there, right? So for now, I given 1,000 values. So these many 1,000 objects is there, right? So it is able to classify. So from my end, like if I give gray fox or else tabby cat or tiger cat or something like that, right? So it will be able to predict. So lion, tiger, cheetah, and those kind of things it will try to predict. For example, if you have one more iPod, I'll try to check. I'll download this one. So see if you can see over here, right? So it predicted this was an iPod. So whatever the list I have over here, sorry. whatever the list, thousand different objects are there, right? So only these many I am able to classify. So this is not the limitation. This is like just 1,000 object I have kept. So if they already have trained data set of other object also, right? So we can use that one. We can just mention, for example, they would be having comma. So if I have a new object, something called as ball, so I can mention it over here and I can just try to predict that one later. So this is what ImageNet labels.txt is there. Okay, so two main things, labels and then weights. So it has to be there. Then what we do is like with open, like whatever it's there, right? So we'll pass these things to your OpenCV. OpenCV is like a huge repository where multiple models are present. So we don't have to deploy the ImageNet from scratch. So I don't have to work on creating each and every layer. So this way, like we'll save some time and we will utilize some other works was already developed. Then we pass this labels.text and weights to the OpenCV model. So we don't have to worry about that one. And then once that is sent, right, so it will be able to predict, do the calculation, and it will try to predict. So whatever I do the like first thing, this post method, what happens is that, so this is just related to your front end part, web application. So post, I'll just select the image and then save it over here, upload and predict. So that is what post does. So it will take the file and then whatever the file it requested, it will pass for your calculation. So this is that part, upload and pass to your OpenCV. Before this one, this is sending this part of the code. And then we have one more image is equals to cv to dot im read. So this uh, OpenCV has inbuilt function. So it will automatically read your image from the file path, whatever we are giving, and it will try to predict from the given weights and your labels. So it will take your labels and weights. So from that, it will try to predict. So whatever it predicts, right? So prediction, uh, the value it will come. So it is trying to give it as your confidence level. So what that prediction is and what that confidence value is about. So prediction and confidence value it will try to give you. This is for the image classification. So any doubts on this one? Anyone, any doubts?
Excuse me, sir. Could you like please explain about weights a bit? Like did not
Okay.
understand.
Weights you don't have to worry about. So as I told you, right? Mm, so there are these many CIFAR data set. So they would be having for each and every object. So this labels I had given, right? So aeroplane, those many things. So they would have already added over there. So for each and every label, for example, label cat or dog, each object is there, right? So there will be having 1,000, 10,000 of images. So they have that huge repository of data set. So when before classification, right? So in neural network, what we do is like we'll train the models. So when we train the models, this one, if you can see, so where was that? To the visualization. So when we train the models, right? So you can see this values over here somewhat. So what weight does is that like it will be having these values. So these many values it would be having, and then it will try to keep store of those values in the weights. So once we give any image right at the end, so it will take the weights value and it will try to compare from the given image and it will try to predict what that image is. I'll just tell in simple words. So weights are nothing but these values at the end, whatever is there, right? So these many values. So somebody would have already trained and we'll just keep it somewhere else. And then when we give some image, right? So this is what image we are giving as of now. It will try to calculate everything. So once it's calculate, right? So whatever the weights is there, it will try to compare for that object and it will try to give the prediction. So that is what weights are. Classification. In order to like understand what more about weights, right? So category. So you told like there will be some differences, right?
Yes, sir.
So this weight contains this patterns. So this nose pattern for dog it will be separate and cat it will be separate. So that weight would be containing these values.
Okay, sir. Like it will match it if the image we
Yeah,
give has that feature.
yeah. So that is what the advantage for us when we use already pre-trained weights.
Okay, sir. So like the
So
information from the data set that we train the model with will be used to create the weights.
yeah, from
Okay,
the
sir.
data set when we train, it would be used to create the weights. So in our case, we'll use the somebody has already created that weights, and we'll use them, and we'll just try to kind of in order to bypass the training everything. So we'll just predict at the end.
Okay, sir. So then like if there are more weights which are matched, then the confidence will go up.
Yeah, if there are more patterns, right? So if you can see this pause, other things, this fur, everything, like it will try to have that weights. So if more weight it matches, so more confidence level. So it will tell us 100% it is dog, even though like without your what do you call even with you also without you telling for the AI system, so it will automatically tell 100%. I'm sure this is a dog and this is a cat.
Okay, sir.
So others any doubt? Be there for the moment. So this one I've shared, right? For your reading. This one is for your reading. Okay, I've shared. Okay, so go for you can click on this button. Go to multi-object detection. You can click on this one. So it will take you to next web page. So what we try to do is that mm, what's current person. For example, we'll take this one. So for object detection, I showed you, right? Three things you can do: classification, segmentation, and object detection. So detect object. So if you can see over here, right? So ours it gave me this image. Also you can see it gave us cow prediction 49%. So cow also has some similar features, right? So it has four legs and this body shape. So for that reason it gave me as cow as some prediction or some part. And then this one car it's hidden behind. So I'll choose one more image. So if you can see over here, horse it has detected 89% and car has 78%. So this is one example of object detection. So that part of the code also I'll explain. Mm, If you come over here, in app.py is there, right? So in depth, like we'll do in next session also, if you are not able to understand with this one. Okay. So as I told you, this whatever part of this code, this part of the code, what we do is like we'll just take the image from the web application, we'll just load that one, and then we'll just pass it to OpenCV. So OpenCV will read that file, and then it will try to do the classification. So object detection, if you can see over here, right? It has drawn in a bounding box, red color bounding box, the prediction and the what is this percentage of like how confidence that is. So confidence level. So three things we have to make sure in order to like draw on the image itself, right? So we are utilizing this part of the code. So for whatever things it has detected, so range of detection, what this range of detection is there, right? Two things it detected, horse and car. So for horse, first I'll take the horse, then I'll do the confidence detection from which part to which part. Mm. So from whatever is there, right? So from year to year. So it is telling me that, so this part is from the image is horse. So that is what this detection 0012 is there, right? So that is for the bounding box dimension. So we are just trying to give the bounding box this one is the ratio, how much it has to match in the whole image. And then it will start x, start y. So y value, x value, like kind of it will take. So four boxes, 4 points it will take, and it will do the box uh, mapping in the image. So for that reason, this part of the code is utilized. And then whatever it's there, right? So it will redraw on the image, the given image, and it will give the result part. So this is for multi-object detection part of the code. So any doubts in this one? So similarly also, we're using the same weights and the labels. So it's already called, right? So we don't have to call once again. So any doubts on this part of the code? Anyone, any doubts? There's one more website for this one where you could have downloaded small videos. Yeah, this one you can use. Mm. Take this one. Let's see. Small video would be downloaded. I'll just share this link with everyone. So where I can use multiple videos also. This one also try to download. So also make sure like you're downloading the small video size, so you don't make your system hang. So 426 into 240 also is fine. Okay, it's too small. Sorry. So you can take this 916 to 540 here. So you can go to the web application which you have created, right? So if you go back and you can go to view go to video detection over here. So I can choose that video. So just right here. Open. Don't have any detect objects. If you give large pixel, like large quality of video, right? So it will take time to detect the object in the video, even if it is small video. So we will give some time for this one. So it's still loading. If you can see over here. So till that time, like if you have any doubts, whatever I've explained till now, right? So if you have any doubt, you can just ask. So if you click on this download processed video, right? So it will download. So it's just telling this is the person out there, right? So it's trying to detect. And if you can see at some point, it will try to detect for this lady. So and it's giving me as other thing also, right? So chair or something like that. So accuracy depends on like how you train your model. So since we have used someone else trained, right? So for that reason, these accuracies are very less. Choose file. One more video which I download. So any doubts on this one video detection as of now? Mm, I'm audible, right?
Yes, sir.
Okay. So any
Yes,
doubts you have, clarify now. So it will take some time. Yeah, it's done. It's able to detect this aeroplane also over here. If you can see aeroplane over here, and this person whenever they're trying to walk. that it able to detect the aeroplane above if you see over here, and then person it's able to detect.
Excuse me, sir.
Yeah, Tanishka.
Sir, I got an error, like I couldn't upload.
Okay, can you download the image video file, right?
Yeah, sir, I like downloaded and uploaded it here, but I didn't get the video.
So this one I've shared, right? Everyone with everyone. Okay. So I'll stop sharing for a bit. Yeah, Tanishka, you can share your screen.
Oh, yeah, sir. So is my screen visible?
Yeah, it's visible. You can click on upload and detect objects.
Sir, I did.
If you can see in the top right, it's loading that. Okay, I think so that pixel size is very large. Can you go to that video download? That website you can go there, right? So you can click on any video which you want to download. So click on that any one video. So if you can see this free download is there, right? So one down one. 640 into 360 you can select. No, don't do full HD. 640 into 360. Yeah. So download selected size. Okay. Go back to that our application. Refresh. Choose file. And the new file which we downloaded now. So upload and detect. I mentioned, right? So as I mentioned, if you take more quality video that is more than 720p, so this error will comes because whatever this model is trained on, it will only accept up to 720 pixel. That's it. So you can double click that Tanishka result.mp4. It's giving me as bus over there. So because in other countries bus is yellow color also, right? So it will give us bus also as the prediction. You can check any other video and download and check. So make sure video quality size pixel size is 360 pixels, 640 into 360.
Yes, sir.
So can you download any other video if person is walking or not, or any other video?
So can I download this one, like car and
On the
person?
right side one, aeroplane, car, and person.
Uh,
The right side one, yeah. So we'll see that how it will predict. Yeah, you can select that 640 into 360 only. So it's loading. You can see, no, wait. You can see that blue color thing in the top. Yeah, it's done. Download processed video. Yeah, car, person, and aeroplane it's able to detect, right?
Oh, yeah, so I got it.
Okay, fine. I'll explain the coding part. Like I'll start sharing the screen. Coming into this video detection is there, right? So we are not using this efficient net and image labels.txt. So what we do is like there is something called as another CNN model called as mobile net. So this mobile net we are using. So there is .caf file and this one is your labels file. So this will contains all your labels. So like how ImageNet has labels, right? Similar way for each and every object, these are the labels. And then this cafe model is there, right? Deploy.cafe model. These are the weights. So we can't see this weight. So it has already been trained. So we are using mobile net for this video classification. So what we do is like same thing. We'll take the file using the post method. Then we pass this video to your mobile net weights. So if you can see over here, so this is how CV2 once again. OpenCV handles your video capture. So each and every video is checked each and every frame, and it's trying to calculate the object in each and every frame, and it will give you that output result. So similar way, we are bounding that each and every frame with this bounding box, and then we're adding those confidence level and prediction, and then we are giving it as result.mp4. So we are saving it as result.mp4. Then that is how your video classification is done. So any doubts on this video classification code? So three things. We are using mobile net weights and labels. Then loading the video. After loading, we are processing using OpenCV. After processing, then we are trying to put the bounding box in each and every image, like video frames. And then we're compiling it to result.mp4, and then we're giving that as output. So any doubts on this one? So for your understanding, just make it little bit of understanding as of now, because this is huge concept. But in order to make you to understand, like I'm just making it this short. If you have any doubts, you can ask regarding this image classification and video classification.
Excuse me, sir.
Yeah, Tanishka.
Sir, can you teach this video classification again?
Okay. So this also has one four main parts. So one is that will request the file. So that is how you're doing this one, right? Video object detection. Close others. So this choose file and these things are handled by this file path. So this file and file path. So this is handling. So it will take the video file and then just pass it to OpenCV. Then what OpenCV has is that it has video capture. This video capture, what it does is like it will handle your video files, cv dot video capture. So once we pass this one, right? So if you can see over here, I'm just mentioning the width and height, what has to be the maximum height, what has to be the uh, width of the image. So that is why I told you like download 640 into 360, right? So this has some limitation. For that reason, we are just mentioning that one. Also, like it will automatically take from the video also. CV2 cap prop frame width and frame height. So it will automatically take from the video, even if you give smaller video size also. So it will take those everything, and then it will try to do the classification for each and every frames of your video. So how video is created, everyone knows, right? So this is just a sequence of images. So video is just a sequence of images. So everything is compressed together. So it will be made into look like a video. So moving objects. So for that each and every frame, what we do is like we do have the object detected bounding box and the prediction and classification results. So it will be displayed on that itself. So this part while cap is open, what we do is like we'll just add the bounding boxes for all the objects detected, and then at the end what we do is like we'll just save as result.mp4 after detecting the objects. Any doubts on this one? Tanishka, still if you have any doubts you can ask.
The from line 236.
9 to 36, once I told you, right? So what we do for each and every like video is sequence of images, right? So it has video has something called as frames. So in order to make you understand, mm, s- see, whenever there is something sequence going on, right? So like for 2 seconds, let's just say this object is here and it moved to the right hand side. Mm, okay. So what we do is like a video is something like it has frames. So this one at this point, so object was here, then it moved over here, then it moved and moved, right? So at the right hand corner it came. So this is what we call as video frames. So this is nothing but your images put together one after the other. So do you know something about what is that frame rate or pixel rate, what we call refresh rate or something like that? So every 60 seconds there is something called as 60 hertz. Sorry, 60 hertz is equals to, for 1 second there will be 60 frame played at that interval. So can you find the difference over here, Tanishka? So this man is throwing something, right? So in first frame he holded the object, then he just kind of kept it at the back and throwed. So this is how his action from first frame to last frame. So when we are trying to do the object detection, what we do is like we capture each and every frame. For each and every frame, we do try to add the bounding boxes, that green color box and prediction and confidence level was there, right? So we'll try to add for each and every frame, and that is how your result.mp4 is compiled together. So we are editing that video inside, and then we'll give it as result.mp4.
Yes, I got it. Like for each frame, like it tries to detect.
Detect, yeah. So that is why if you can see at some point it was not able to detect that person or aeroplane, right? So that is what is happening. So at one point it was not able to detect, so that it automatically went that prediction part.
Oh yeah, so like later we got to see the aeroplane.
Yeah, that is what is happening. Even though it is there, sometimes it doesn't detect. So for that reason, there will be some mistakes from AI classification. But if you go for advanced convolutional neural networks, right? So these errors are very minimal. So we won't be able to notice.
Yes.
Everyone, is your doubts cleared? Or if you have any doubts, you can ask. So we'll go for AI game creation next. So how did you find this part? Did you find it interesting or boring, or did you learn something new?
Yes, so it was very interesting. I thought so.
Okay. Okay, once you go in depth, right, it's very interesting even more. So for student level, this is the very basic. But if you go, like if you study, take computer science or in future, right? So you'll go more in depth, like what is happening in each and every layer, like how it is calculating. So you'll get to know those and all. Okay, so I'll just give 2 minutes break. Everyone can try this one, or else if anyone is having any errors, you can just message me, or you can just ask. Sorry, not messaging. You can ask over here itself. Or else I'll see one by one. Everyone can share one by one, and you can start showing your output. So whenever you're coming for next class, right? So what improvement can you do for this one? You just got the idea like object detection, those kind of things, right? So think of something like where you can improve this one, image classification. I did the very simple one. So how do you showcase this application from your endpoint of view? Your creative idea I want to see.
Excuse me, sir.
Yeah, Abhishek.
Can you once again repeat? Because I had lots of internet issues.
Sorry.
I was not able to hear what you were saying until now. So, can you once again repeat it, sir?
Abhishek, we are short on time. I can't repeat from starting everything. We have to
Sir,
see
like
one more.
the last I heard of half like 40 all 75%. You can say the last ending part of it.
Last ending point was the video thing, right? I have to explain everything. There is one more like you can after this class you can see the recording once again. Is that fine?
Mm.
Because Abhishek, like it will take a lot of time. Like this one more is there, right? We have to see for AI game creation also.
Okay.
Yeah, okay. You can just go through the recordings. I've explained it clearly once again. You can go through the recordings afterwards. Okay. So we'll start with AI game creation. Before that one, I'll just give the code for you also. Mm, I'll just upload in GitHub. Just give me 2 minutes. I'm uploading now. We'll start. I've uploaded the code. So I'll start sharing my screen here. Okay. So if you go to this mini project, right? So GameBot has been added now. Just now I've added. So you can download the code once again, or else if you can download this particular only this GameBot also, that is better. So download, same thing, download zip. It will download and you can extract that file. So once it is downloaded, right, you can extract. So many projects. So along with that one, you got GameBot. So inside this GameBot, there are two folders. So as of now, like for initial thing, So you can just go for game board folder, and you can open that in your Visual Studio Code. So file, open folder. So like for me, it's in mini project. So I'll just go into game board. So I'll just select the folder. In your case, like whatever you downloaded, you can just go over there. So I'll just share one link with you. So if you open this one, like you'll get this one website. So where you can play tic tac toe. So what I wanted to do is like I want one student who can open this web page and play that one. Who can play this one? Leo.
Yes, sir.
Okay, it's not playing, but what you're doing is that whatever you play, the AI is getting trained on that values. So you can just go over there. You can share your screen also, Leo.
Yes, sir. Uh, just a second.
No, what you did is right. So what you did is like X and O you only played, right?
Yes, sir.
So which has 1 hour here. What is the winning pattern?
Yeah.
You don't have to click on like I would have told you like what to do. So
Okay.
can you refresh the page? Can you play one game? So which one now?
The X.
Okay. So what we're telling the AI model is that. So if you can see over there, right? Train AI to play like X.
Yes, sir. Should I click on it?
Yeah, click on that one. So how the text player played, right? So it will train on that one. So you can play one more game. So if you can see over there, AI has learned from one game. So you played one game, it has already learned that move. So you can play next game. So which one? You can train AI to play like X. Okay. Once again, you can click on that one. Okay. This one, Nitish. Can you be O and you will be X? You can mention where to place.
What's a
Like Leo would be X value, X player, and you are the O player. So
uh,
Leo, you can place one. You can play with each other for once. Leo can play starting like wherever you want. First move you can make. And Nitish, where do you want the O to be?
left corner.
Left corner. Okay. Okay. You can play next Leo.
And
Okay. Where do you want the next one to be, Nitish?
mm, I think left below bottom corner. Left bottom.
Okay.
Yeah, this.
Uh, so Leo, you can place next. Then Nitish.
Mm, the middle end.
Okay. That one. Middle. Yeah. That one. Yeah.
Bottom middle.
Bottom mid. So no one right. No one was able to win, right? So Leo, you can train it like O as of now. play to train it like code. Okay. Now Abhishek and one more person. Abhishek and Maria, can you play? Like Leo, you can just place it where they tell.
Okay, sir.
Okay. We'll start with Maria, your ex, and who is the other one?
Abhish.
Abhishek, yeah. You can be the O.
Okay, sir. The center, the middle one.
Place the O at the top left corner. Not there. Yeah.
It's already been placed. Okay. Okay.
Um,
Maria?
Middle bottom.
You can place at the up corner. Up. Yeah. Middle. Middle. Up middle.
Maria?
Top right.
Yeah.
Bottom left.
Um, Left middle.
Middle right.
Yeah, one more you can press X. Yeah. So you can give train like X. Train AI to play like X. Yeah. So what we're doing is that we are just training the AI model. So the players will play like this. So you also learn this pattern. So Leo, you can click on about this project plus. That corner is there, right? Bottom corner. So download current AI model. Yeah, you can download that. Yeah, save. Okay. What we did now is that simple TensorFlow has already released this one. Mm, what they did is like they just kept the open source AI model where it will train on the player's data. So we gave that data by playing the game, and we don't. Uh, Leo, you can mute that one, and you can stop sharing. So what Google did is like as I told, they made the open source code, so where they kept the AI model to train on the user data. So what we did is like we played some games on tic-tac-toe, and we gave some training data to the AI model, and it just gave us the training data, whatever it trained on. So it trained on that values, and it got the values. So what I wanted to do is like we have to download Python 3 less than 3.10. So so I'll just share my screen. Sorry. So you don't have to try this one. I'll show it to you. Like once you're okay with downloading 3.10, right, Python, then only you can do. So what we need to do is like Python 3.10 download. So because TensorFlow doesn't have compatibility with other Python versions, so with less than Python 3.10 or something like that, it will be able to use. Press Windows. I don't know this. So what I'm doing now is like I'm just removing the current version of Python. So I'll share this link also. Later you can try. So I'm just installing this Python 3.10 version. So I'm just making sure I've installed the Python. CMD. So Python 3.10 I've installed. Okay. Visual Studio Code. I'll just reopen this once again because I've installed the new Python, right? So it has to get familiar with that 3.10 version. Okay. So Python 3.10 is there. Okay, fine. So, okay. I think so when you're installing this Python 3.10 version for the first time, right? So let me install TensorFlow will come. This one you need to install. So just copy paste and you can install once you have installed your Python 3.10. Just a minute. Import. Okay. So this is simple. As of now, Leo played some games and he got this TensorFlow tic-tac-toe game model.json file, right? So what it has is that it has the JSON files where it already learned from the values. If you can see over here, so many values are there. So these are the values like it will be storing. And then we have game.js. So what game.js is that it will land like this has been built on Flask application, right? So what I've done is that like I have to take the player move. So I have to take their position. Like I'm the player. There are two players. One is AI player and other one is myself. So player move and then bot move. So what I do is like first I'll play, then the bot plays. So these functions are written so in game.js file. So you don't have to worry about that much. But I'll give you the basic idea. So first thing, I'll see the player move and then like whichever the position. So if you can see this one, right? No, I'll just take paint. It's better. So how many square boxes are there in tic-tac-toe game? Anyone?
9 boxes.
Okay, 9 boxes. So, like, if there are 9 boxes, right? So, how many times can you place characters in each box? So, 9 times, right? So, 9 times you can place without repeating. So, there are 9 moves in this game. So, I just set the rule. So, there are 9 rules, sorry, 9 boxes. So, I'll get the position of those 9 boxes. And then there are total number of 9 moves which I can get. So, whatever trying moves I'm trying to get, right? So which move I'll try to calculate. So if it is first move, I'll try to do that first move. Bot will do the second move, and so on. So after that one, there is something called as function update UI. So whatever we are updating, right? So both player as well as AI bot. So it is updating. So updating the front end, and then reset game. Reset game is nothing but I'm just filling that whatever the UI is there with zero values, null values. So that will completely reset the game. So what are the possible winning moves? Can anyone tell me? So winning moves. How many possible ways? Pranava?
So winning moves means like what?
Like what are the winning moves? Like if I get this X over here, right? So this is win. So if I do same this one, this also right. How many possible ways are there? Can you list it out?
The six.
Okay. So one, two, three, one, two, three,
Hmm.
and then one
So horizontal. Okay,
horizontal and vertical. So total
so and even the like diagonally.
diagonally. Okay. So diagonal method. So then
I guess only
no other
that.
possibilities, right?
Yeah.
So what I did is like so in order to move right, so in order to win patterns, so I given this 8 possible ways. So all the rows it will if the win pattern is same right, so they are the winners. All the columns if they are this same character values, they win player or bot. So then the diagonals. So this is the winning checking function. So three things. One is the player moves, then game bot AI bot moves. Then we have updating like just whatever they move, right? So we'll update in the front end, and then there is the checking pattern like winning pattern. Sorry, winning pattern, and we are checking that what are the possible ways a player or the bot wins. Okay, so this is just simple HTML file. So what we do is like the player moves we try to calculate, right? So it can be either player or game bot. So cell ID we are given. So it will start from 0 to 8. So 0 to 8 is nothing but total 9 values, right? So it will start from 0th move and end at 8th move. So I'm just updating. So just gave the cell ID. So just run this code. It's already running, right? Yeah. So simple tic tac board. So what I did is like I already downloaded from over here, right? So the same thing, JSON file. I downloaded it and it's already there, so you can utilize that one. So this JSON file is trained on around 10 games, but you can train it on 100 games, 200 games, and you can just save that one as well. So you can utilize that one. So coming to our game, so if I play X and O, the O will automatically comes. So if I do some more move, right? So X, so it stopped me over here. So I'll do my X over here. So O it came and I win. So like how I win. So X games. So any doubts on this one? So you can also try this one.
So is it like if we train more games, then we get more accurate results?
Yeah, if you train it on more data, right? So if you play like
Mm.
50 games and you play, so it will you won't be able to beat that one. So it will be knowing all the patterns, right? So it will learn from that one, and it doesn't let you to win.
Okay, so
If you want to make it easy, train it on less data. If you want to make it on medium level, you can just train it for 10 games. If you want to train it for very difficult, right, 100 games. So that improvement you can make. So three things you can add: levels, easy level, medium level, and what is that? Difficult level. So if you train more, difficult it becomes.
okay, so
So any doubts, anyone? So, any doubts if you have, you can ask now. So there are one more thing, right? It's okay. So if I remove this one and comment that one, in the same code itself. If I do, so sorry, so wrong code. I'll remove this part. Sorry. So control Z. So if you go to one more file, is the right file? Open folder. So gamebot UI is there, right? So if you go over there, same thing, but it was made to look more attractive. That's it. So this is just made added background and so many things in order to make it look cleaner, right? So it was made this way. So I bought one. So if you can see, it got this way. So I think so. This was trained on around 20 games. So bot was able to win. So any doubts if you have, you can ask now, or else it's already 6:45, right? Yeah, we'll wind up this session. We started at 4:50. Yeah. Any doubts? So if I come to this TensorFlow model, right? So it is just using your basic DNN model. So DNN models are nothing but I've shown. Uh, just a minute. So if you can see different neural network model, right? So this one would be around RNN model or a deep feed-forward network model. So based on number of layers, they would have written the TensorFlow model, and then they would have utilized. So any doubts on this? If you have any doubts, you can ask, or else we'll wind up this session.
Excuse me, sir.
Yeah, Tarisha.
So you told that if like we can make any improvements or variation in the given format, like what kind of variation like you told us to?
It depends on your creativity. It can be either front end part, or else if you want to do improvement for your AI model as well, right? So you can do that as well. So as some now, someone told, right? So if I train it on more number of datas, that game will become difficult, right? So in order to win, so it will be having more patterns. So that is one creative way. So easy, medium, and difficult. So we mentioned that way, and I just got the idea. I can do it that way as well, right? So think of something like where whatever you learned, right? So how we can use it differently. That's it. It's not
Yes,
like you
sir.
have to you don't have to create something new model or nothing like that. So I want that creativity level. So whatever you learned, how you will use that one in more different way. That's it.
Yes, sir.
Okay. So if you have no doubts, like we wind up this session. If you have any doubts, you can ask.
So like we will get the doubts when we go through the codes.
You better go through the codes and try that one multiple times, and then we'll see in the next class on Wednesday.
Yes, sir. So can I stop recording then?
You can stop recording. We'll wind up this session. Yeah. Thank you, Tanishka, and thank you, everyone.
Thank you, sir.